Good afternoon, all. Okay, let's start the class. Hope you all have completed your student registration. So, if not, try to complete it and then start preparing for the abstract for your project. So, when is the last date I have given for the abstract? 25. So, 26 I will be asking. Okay. So, before that, everyone should submit. And last date for student registration is 15. So, before that, you have to complete the student registration also. Okay, otherwise, whoever is doing the student registration later, that will get rejected. Okay, so in yesterday's class, we have seen about clustering, right? We have seen about clustering methods, and then, we have seen about what is clustering, and we have seen one algorithm which uses the clustering and what technique it used. Can anyone say? We saw k-means algorithm, right? So k-means algorithm used centroid based clustering. Similarly, we are having various types of clustering. So those types only we are going to see those types, and then how it is actually work in the back end, how it is calculating the closest value. Everything we are going to see in today's class. Okay. So first type is centroid based method. So using the centroid based method, we use the algorithm called k-means algorithm, so which we have already seen in the previous class. Okay, so k-means algorithm is an unsupervised learning algorithm. Okay, it will try to help you to solve the problems which are related to the clustering type. Okay, then in the clustering type also what it will do, it will try to group the values of same feature, okay, or similar feature we can say. Then only thing we have to do from our side is we have to specify how many clusters you want to create. Okay, that is why we are mentioning as k means, right? So k represent number of clusters you want to uh, create in your data set. Okay, so assume that you are having a data set. Okay, like this you are having one data set, and this is what you want to be as your final output. So k value you are going to give it as 3. Okay, and assume that we are having three different color buttons. Okay, or points. For assumption it is a points. So like this you want the output. Okay, this should be one cluster, and this should be another cluster, and third should be this cluster. Excuse me. Okay, so for that, what we are going to do and how we are going to do, we are going to see. So we have already seen that what our algorithm will do. Our algorithm will randomly pick three position. Okay, initially assume that it is picking from the data set which we have given. Okay, so for assumption it has taken 3 points. Okay, green color has been placed here, and then orange color, and then red color we are having. Okay, out of this 12 points, 3 points has been randomly picked by our algorithm. Okay, so now what will it will do is from each point, so we already know where it is going to place the point. The only thing is we have to come to a conclusion that which cluster it is going to create. Okay, for assumption this we can call it as cluster 1, cluster 2, and then cluster 3. Okay, of three different color. Suppose I'm asking here I want to place one point. So if I am placing one point here means whether it will belongs to cluster 1 or cluster 2 or cluster 3. It belongs to cluster 1 only. Why? Because the closest distance, a very short distance between the point which you are placing and the cluster out of this three cluster is C1 only is having the closest distance, right? So likewise, what we will do is we will try to find the distance from each point to all the clusters available. So for assumption, if I'm saying from this point to reach this point, it takes 3 points, right? As for assumption, and from the first point to reach the cluster 2, okay, cluster 1, cluster 3, okay. If I want to reach the cluster 2 means, for assumption case, I can say 4 points it has to cross. Similarly, if I want to reach the cluster 3 means I have to cross 6 points, right? So obviously the cluster 1 is very closer to the new point, right? So this will become a green color point, okay, or green color class, whatever you want to say, you can say. Okay, so from this, can you able to say which and all will become green and which and all will become orange and then which and all will become red? Obviously, these 3 points are going to be in what color? Green only, right? Because green only very close to these 3 points. When it come to here, whether both will be this we can say yellow or orange, orange. Okay, so whether this two will become orange or any one only will become orange. Hmm. Only this will become orange. Okay, why? Because the distance from the cluster to the orange button to the this point is more when compared to the cluster 3 and the point. Right. So this will convert it into orange color and this will become red color. So now if I draw a cluster, what will happen? This portion will become one cluster. Only 2 points will become cluster 2. Okay, and remaining points will become green cluster. Okay, or green buttons, which is not correct, right? So like this, okay, as I told, it will try to add one new point. So since it is closer to green, so it will convert it into green. So likewise, for each iteration, for the each point, it will try to perform it. So this is how we will get the output in the first iteration. In the inside the algorithm, this is how it will work. In the first iteration, if you see the output means this should be the expected output, right? But this is the output we got in the first iteration. Okay, so now what it has to do? Again, it will choose another three different position. Okay, so again, so if I'm moving to the another position, previously green color was here, right? So that has been slightly moved to another point, and here we had red point, and here we had the orange. So orange remains the same. Okay, whereas red and green has been moved from its original position in the second iteration, right? So now if I perform same operation what I had done in the previous step, so this is how I will get it as the result. Okay, all this 5 point will become one cluster. Now I'm having three orange points and then four red points. So here, which one is completely correct? Red point has got its correct 4 points, whereas the green point got one extra, and in the orange color one we have lost. So again, it will go for the next iteration until it reaches the exact points. Okay, then in third iteration, what I am doing is I am moving green color. So green color was here in the previous iteration, right? And I have moved the orange color also. This time all three random points I have moved from its original position. Orange also moved from this position to 2 points later, and green also moved back to its another position, and red also I have moved from its previous position. Now Again I will perform the same. If I am performing the same operation means, see, I am getting the expected output. So red also I got 4 red value, 4 orange value, and then 4 green value. So this, in the third iteration, I have got the expected output, I can say. Okay. So before doing the k-means algorithm, this is how our point will look like. After performing the k-means algorithm, it will be segregated into 3 clusters. Okay, cluster 1, cluster 2, cluster 3, I can say. Understood? Okay. And we have, when I'm saying about this type of algorithm, I have told it will use one distance method, right? What distance method it will use? Euclidean distance method I have told, right? Euclidean distance method is there, Manhattan distance method is there. So Euclidean distance method means, suppose I'm drawing one centroid, means from this centroid, it will find the distance from that center point to the nearest point available. So same goes for other clusters also. Okay. Now we are going to see with some example. Okay, so before going to the example part, let us see the flow diagram. So how it is actually performing this operation. So it is starting the algorithm and we are specifying the number of cluster. In this case, we are specified as 3. Okay, then it will try to find the centroids. Okay, then it will try to find the distance object to the centroids. From the centroid, what are all the closest objects present. Then it will try to group based on the minimum distance from the centroid, whichever point is very closest to them, it will try to group it into single cluster. Okay, and it will check no object group. If any no object group is there or not, it will check. If no is your answer means, again it will start its iteration. Okay, iteration 1, iteration 2, until this become yes. Okay, until it become true, it will continue this process. Once it has become yes means, it will stop the iteration. Okay, clear? Equal distance is there, Manhattan distance, anything we can use. For example, I mean, if you are going for equivalent distance means, you will get the distance in point values. Whereas if you are going for the Manhattan means, you will get some integer values. Okay. Okay. So this is the example we are going to take. So these are the points. In previous class, I have done right income spent. Two column I have given and I have grouped into pairs. So assume that each pair is a x and y value. Okay, and I have given it as an example here. So in example, previous class example, income will be x and then spent will be y. Right. Similarly, here also we have taken 8 points. Okay, and 8 points x and y axis we have given here. Okay, and we are going to take 3 cluster. Okay, so from this 8 point initializing, initially I am taking 3 points from the data set itself. So from this 8 points, I have taken this. Okay, and then P for fourth point and then seventh point. So keeping this as the initial point values, we are going to find the distance. Okay. So distance between 2 points is a is equal to x1 comma y1 and b is equal to x2 comma y2, and you all know the formula, right? For Euclidean distance, what is the formula? Square of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? This is Euclidean distance formula. Manhattan formula means only x2 minus x1 plus y2 minus y1, sorry, absolute value. Okay, even if we are getting a negative also, we have to convert it into positive. Okay, this method it will be easy when compared to Euclidean distance in case if you are performing. Okay, so formula I have given. So 2 points, any 2 points. Okay, for Euclidean distance, we have to use this formula. Whereas if we are going for Manhattan distance means directly we cannot draw a line. We have to draw some proper line. Okay, and this is the formula. So you can put x2 minus x1 or x1 minus x2, both are same only. Why? Because anyways it is not going to give you negative value, only positive value only it is going to give between 2 points. Okay, now so we have chosen the which distance method we are going to use, and what are the data points we are going to take, and what are all the centroid points. 3 points we have taken for centroid, right? So all information we have got. So using this information we are going to create this table. Okay, so I will explain you how this values has arrived. Okay, here if you see means already we have taken the point 4, right? This is point 1, point 4 and point 7. So randomly three values has been taken and marked as cluster 1, cluster 2 and then cluster 3. Then for each point, for the 8 point, we have to compare with the cluster and we have to find the Manhattan distance. Okay, for the same point, if I am trying to find the distance means what will happen? Distance is going to be 0, right? From that point, if I want to go to that point means 0. I don't need to move. So it will become 0 here. Okay, I will mark here. Wherever, whichever point I have taken, that will obviously going to become 0 because same point I'm not going to travel anywhere. Right. So in this case, I'm going for second one. Second cluster having a point as 5 comma 8 and another one point is 2 comma 10. So 2 comma 10 is there, 1 point, and then 5 comma 8 is there, the cluster value. So this is x1, y1, x2, y2. So if I put it in the formula means exact formula if I want to write means x1 minus x2 plus y1 minus y2. Here x1 means 2 minus 5 plus 10 minus 8. Output is minus 3 here, but since it is in uh, modulus, we just have to give 3 plus 2, which is 5. So this value is has been placed here. So likewise, we have to find for cluster 3 also. Basically, we are finding the distance from this point to the cluster point. Okay. Similarly, we are finding for all other 8 points. Okay, for all 3 clusters. Here I have taken only 3 points. So we are doing for 3 times. If you have taken means 3 in the sense 3 into 8, which is 24 times you have to do this process. Maybe from this 24 you can ignore this 3 because we know the value is going to be 0 by default. Okay, so once you have calculated this, okay, up to here only we have seen, right? So how I have written cluster 1, 3, 2, 3? Can anyone guess this? How I have given this cluster value? Okay. So how I have given is out of this 3 value, which is the minimum value? Which cluster is having the minimum value? So that is the closest to point to the cluster, right? So out of this 3, 0 is the minimum value, right? And which cluster is having that minimum value? Cluster 1. So I have given as 1. So 1 is nothing but cluster 1. Okay. Similarly, in second case, 5, 6 and 4 is there. So 4 is the minimum value. So otherwise I will change the color. Uh, um, okay. So here 0 is the minimum value and in this case 4 is the minimum value which belongs to cluster 3. Okay. And in the third point which is very closer, C2 is closer. Okay. Then in the case of point 4, C2, again C2, so I have given 2, and point for point 5, 5 is the minimum value, so again C2. For point 6 also, 5 is the minimum value, so again C2. And for point 7, 0 is the minimum value, so C3. And for the final point, 2 is the minimum value, so again C2. So here if you see means C1 occurred only one time, C2 occurred 5 times, right? 1, 2, 5 times. Then C3 occurred for 2 times, right? So next step, so in the next step what we have to do is to recompute the new cluster center. Okay, we have to find the mean. Okay, this is important. K, the name itself it is given as K mean only, right? So we have to find the mean here, and then the center of the cluster is computed by taking mean of all the data points contained in the cluster. Okay, so how we have to do that is given in the below steps. So in the cluster 1, when you take the cluster 1, we are having only one point, so it is going to remain the same. Okay, no change in the cluster 1. Whereas when you come to the cluster 2, 5 points are matching, right? So to take the mean of x and y, very simple. We have to add all the x value and divide by total number of x. Similarly for y also, add all the y values and then divide by, here y we have given 5, because 5 points we have taken, right? If you are taking different number of points means different number it will learn. Total number of points. Okay. So in simple terms, sum of all x by number of points. Similarly for y also, sum of all y divided by number of points. So here if you see means I have done the calculation. 8 plus 5 plus 7 plus 6 plus 4 divided by 5. I will get one new x value. Similarly for y if I do means I am getting another new centroid position. Previously my centroid position of second value is 7, I think 5 comma 8. So now it has changed to 6 comma 6. Same goes for cluster 3 also. In cluster 3, I am having only 2 points. So 2 plus 1 by 2 and then 5 plus 2 by 2. So now I got the point as 1.5 comma 3.5. Okay, so cluster 2 value and cluster 3 value, which means centroid position alone changed. Okay, now with the new centroid position, again, I want to calculate the mean distance from the actual point to the center points. Okay, so if I do that means only this point will be 0, no other points will become 0 because 6 comma 6 is not present in our point. Similarly 1.5 comma 3.5 also not present in our data set, existing data set, right? So it is not going to be 0. And if you see the new cluster values, see, previously we had only one cluster, one C1, right? But in this case, how many C1 we are having? We are having two C1. C1 here and then C2. Previously we had 5 C2, but now it has been reduced to 4, right? So 4 C2 values is there. C3 remains the same. Same 2 only is there. Okay. So same formula, same calculation only. So no need to, you know, again explain it to you. Now, what we have to do? Again, we have to do the mean process. Okay, this time for C1 also we have to do. Okay, and for C2 we will get different output, and for C3 will it change or it will remain same? Any guess? It is going to remain the same. Why? Because in the previous table also second and seventh second and seventh point become the C3 point. Okay, here if you see means the second point and seventh point was the cluster 3 point. Now also same point we have got. So this value is not going to change. Okay, so it is a finalized value. So here you can change. Okay, for cluster 1 now point has been changed. Previously we had 2 comma 10. Now it has been changed to 3 comma 9.5. Okay, see slight change only. 2 become 3 increased, 10 become 9.5 decreased. Okay, and for cluster 2 now this time only 4 value. So again previously what was the second cluster value? 6 and 5.5 I think, right? 6 comma 6. Okay, so 6 comma 6 has been changed to 6.5 and then 5.25. So again one slight change in the value, and for cluster 3 it remains the same. So we have to repeat this process. Based on this criteria, when we have to stop? Stopping criteria is the center of newly formed cluster do not change. Okay, in case of cluster 3 doesn't change. Same scenario will happen for cluster 2 and cluster 1 after some various iteration. Okay, in this example we got it in third iteration itself, but whereas in real time it may take some n number of iteration to get this particular point. Okay, and then second criteria is the data points remain present in the same cluster. Okay, 10 points in the cluster means same 10 points will be there. Okay, it will not change between one cluster to another cluster. Okay, that also we have to check. Then finally the maximum number of iterations are reached. Maximum number of iteration here means is if in our assumption we are having only 10 points. Okay, and we have taken 2 cluster or 3 cluster means various combination we can take, right? Out of 10, it is like 10 balls is there. Okay, in a bag, what is the probability of getting 3 balls, random balls? So each time when I take 3 balls means again I will put the 3 ball inside the bag again. So likewise, what is the probability? So when I reached all the possibilities, that time I will stop. Even if I am not able to get the accurate value. Okay, uh, I can able to do only 100 iteration. Okay, 100 iteration I have done, still I cannot able to classify also, it has to stop. Okay, because there is no any possibilities there, all possibility just tried. Oh, so data points remains in the same cluster means here we are getting 4 points, right? Next time if I take different central also same 4 points should come. 8 comma 4, 5 comma 8 means same point should come. That is what it means. Okay, one time it is in cluster 2, another time it is in cluster 3 means changing, right? So that should, it should have same 4 point and the 4 same point should be same. Okay, that is what I mean. It should not be like one on the in the here also you have seen, right? Hmm. Here see here also 4 is there. Here 3 is there and here 4 is there. Okay, each time you cannot say that. Okay, this 4 I will take and green is having 4 points, like that we cannot say. Same 4 point, same number of clusters should be there, not more or less. Okay, so these three condition if we have got, then our iteration will be stopped. Okay, so this iteration is nothing but in the flow diagram you have seen, right? So in this place only these three condition will be checked. If all three condition has any one condition or any condition solved means it will stop the iteration. Otherwise, it will continue its loop. Okay. Then again for this new points, we have to find new value, right? So until it will be having the exact points, we'll continue this process. Okay, I have stopped it here. Okay, we have got cluster 3 as fixed value, and for cluster 1 and 2, okay, not 1 and 2, if you are doing the same table with new points, what is the new point we have got? 5 point, 6.5 and 5.25, and then for this remains the same, and for cluster 1, 3 comma 9.5 I have told, right? So for this you have to find the Manhattan distance between one point to the another point. Like that, if you are doing means after some certain point, this also will become constant. Okay, no any change will be there in the previous value and the current value. That time you will stop this process. Clear? Okay. So there are some disadvantage also in the k-means algorithm. So what are the disadvantages? It is difficult to predict the k value. Okay, we have seen in the previous class to predict the k value what we have done. We used the WCSS method, right? Within cluster sum of square method, we try to find the k value. But there also I have told, right? Using the elbow method, you will be getting output like this. First point to second point, one huge drop will be there. Okay, and from second point to third point, another drop, and from third, fourth point and all, you will be having some same like constant drop will be there. And I have told this also. We cannot say exactly, okay, this is the correct k value. We can give k as 4, 6, 3. Accordingly, it will change its output. Okay, so that is what they are saying it as difficult to predict the k value. Then the k-means algorithm is sensitive to outliers. Okay, from the data points only it is taking, right? Suppose in a data set outlier is present. Outlier means some points will be very far from the actual pattern. That is what we call it as outlier, right? If we are taking that as centroid, that time what will happen? We cannot able to take multiple data points near to it, right? This outlier assume, and all data points are present here. Okay, and this outlier I have by mistake I have taken as a centroid. Mean here v means the algorithm is taken as centroid means all points will be very far from the centroid points, right? So it is very sensitive to the outlier points. Then different initial partitions can result in different final cluster. Okay, so in starting also out of the 10 8 points, I have started with 2 sorry 1 4 and 7 point I have taken. Instead of taking 1 4 and 7, if I have taken something else means it might have taken even more iteration for me to complete these steps, right? As I have taken 147, in the second iteration itself, I have got the third cluster as correct point, right? So then after if I do any further iteration means remaining two cluster also will be uh, matching the best fit we can say. Suppose instead of taken 1, 4 and 7, I have taken 2, 5 and 9, 8. Like that if I have taken means what might have happened? It might have taken even more iteration to reach the process. So it will slow down our algorithm. At the same time, our performance also will be reduced. Right. So that is what they are representing as different initial partition will result in different final clusters. Then it does not work well with the cluster in the original data. of different size and different density. Okay, if you are having completely different set of category, okay, which is not matching with each other, that time it will be very difficult for us to find the similarity between each point. Okay, because based on the similarity only we are grouping the cluster, right? If those similarities are not there, okay, completely different types of uh, classifications or values which you are having means k means algorithm will become more difficult. Okay, because in the second and third iteration itself it has become point values. We started with some fixed value like integer value, but it has become two point values, right? So the increase in the point value means difficult to calculate the Manhattan distance or Euclidean distance. Everything will become more complicated. So that is what they are trying to mean. Then what is the solution for that? So as a solution, we can go for K-Medoids algorithm. So what this K-Medoids algorithm will do is based on the PAM, which is nothing but the partitioning around medoids. So using that technique or algorithm, it will try to find the cost. How much cost? I mean, distance is nothing but the cost. Okay, so for example, from one place to another place, I want to travel. Based on the cost, we will say, right, a petrol cost like that. So similarly, here the distance is represented as cost. So we will try to go for the minimum cost. So whichever point is or the centroid is minimum to the data point, that point we will take it as the closest to point value. Okay, or the centroid. So let us see. Okay, so the difference, basic differences here, the mean value and all we will not take. We will take the mean value differently. Okay, one thing, and another thing is uh, in the k means we have taken mean value and found the new points, right? Like this by adding all the value and then dividing by 5. Okay, and then we have got x and y. So this we will not do. Instead, we will take the points only from the data set points. Okay, only within the given data or the given input, we will take the new points each time. Okay, we will not create our own points. That is another difference. Okay, so initially select k random points. Okay, again here also k medioid, so k value we have to specify. Okay, randomly it will take from the data set. Similarly, how we have seen in the k means. Okay, then so it will take from the given n data points of the data set and are intended to be the most central point of our cluster. Okay, so associate to each data point to the closest medioid by giving any common distance metric methods. Okay, so we can use Euclidean or Manhattan distance. Okay, then for each pair of non-selected object H and selected and object I, calculate the total swapping cost. So we will see what is swapping cost. Okay, with the example, and finally what we will do is select the configuration with lowest cost. Okay, lowest cost means lowest distance. Okay, okay, same. Okay, not same points I have taken a different 10 points. Okay, this is going to be my new 10 points and this is going to be my values of those points. Okay, from this randomly I am taking only two clusters. So to make the calculation very easier, I am taking only k value as 2. Okay, and the 2 point is taken as 5 and 10. Okay, cluster medioid 2 and then cluster medioid 1, and the point is 3 comma 4 and then 7 comma 4. Okay, Step 1. Then in the step 2, I'm going to find the x2 minus x1 plus y2 minus y1. Okay, which is nothing but the Manhattan distance. So two cluster point is there, and I'm finding the distance for each cluster points. Same formula, right? So we know 7 minus 3 or 3 minus 7, anything you can give, plus 6 minus 4, you will be getting 4 plus 2, which is 6. So likewise, we have to fill all these points. Here if I do means what will happen? Here I will get 0. Similarly in this case I will get 0 here. Right, because same points. Randomly 2 points we have selected, like how we have done for the k means. In k means we have given k equal to 3, so we have taken 3 random points. Here also we have taken random 2 points. Okay. Then, so this is how I will get it as final values. Okay, distance. So from this, I have to choose the minimum distance. Okay, same like how we have seen previously also. Out of 3 cluster, we have taken a minimum distance cluster, right? Here also we have to take the minimum distance, but not the cluster, but the value. Okay, there we have taken which cluster is having minimum, but here the value itself we will take. So here 2 is the minimum, 3, 4, then again 2, so it is 0, 4, 3, 1, 1, and then 0. So all the values you have to add. That's all. No any average and all. Just add all the value, which means all the distance value. You will be getting one total value, right? So you have to note it down this value. Okay. Then again I have to take another two random value. Okay. So this time I'm taking the 8th and the 10th value. Okay, you can take any value for our assumption. Like this, various combination will get, right. 10 means 10. So many combination we can create out of this 10 points. 1, 2, 1, 3, 1, 4, 1, 5. Like that. Like this we used to do, right? 10 into 10 factorial, I think. That much. 10C2, correct. 10C2 we will take. Okay. So that many combination we will take. Then what we will do? So in this example, I have taken not going to take all the combination. So another combination is 8 and 10 I have taken. Okay, and I have to do the same process for that two values. Okay, this time I'm getting the distance as 3 plus 3 plus 4 plus 3 plus 1 plus 4 plus 2. So here why I have given blank is anyways it is going to take 0. Here also it will take 0 only. Right, so no need to waste time in calculating. So if I add all the values means I will get what? 22. Now, so already one value we have got, that is 20, and this time another value we have got, that is 22, which is increasing or decreasing. So cost is increasing. Okay, so obviously what we will do is, so based on our calculation, our cost is increasing. Previous cost, present cost minus previous cost I'm doing. The value which I got is greater than 0, but the expected value should be less than 0, which is negative value. Then only it will switch to the present value. Otherwise, in this example, which cost is very less, 20 is less. Likewise, it will find for all the combinations available, and out of the all the combination, which is having the very least cost. Okay, suppose 2 3 combination has the same cost also possibility is there, right? From that you can choose any one cost because same cost, so you can choose any points, right? No problem in that. So here only it will take from the data points which you have passed as an input, not from the like how we have created in the mean k means. Okay, so once it has found that the previous points itself having less cost value means it will swap. So this swapping is nothing but the swapping cost. Okay, as the swap cost is not less than 0, it should be less than 0, but it is not less than 0. So we undo the swap. If it is less than 0 means we will do the swapping. Swapping in the sense we will move from this point to new point. Okay, so hence what we are doing, we are coming to a conclusion that 3 comma 4 and 4, 7 comma 4 as our final medioids. Okay, here I have taken only two combination. So from that I am taking the first combination itself, the best one. We in the sense the algorithm will do. Okay, all the 10C2 you have told, 10C2 combination it will do. Uh, which is having the minimum cost it will take. In case multiple combinations having same cost value means any one value it will take. Okay. Uh, K medioids value, that medioid value. Okay, since this also clustering type, I mean centroid based clustering only, but here centroid will be of any data point, not like random points from a random point only, but not randomly placed in our graph, randomly placed between the data points. Okay, so this is how we will get the final output. 3 comma 4, 2 comma 6, 3 comma 8, 4 comma 7, one cluster, and remaining all will become another cluster. Okay, understood. So this how I have concluded. So here you can see, right, whichever points I have taken as minimum value in C1, that and all belongs to C1 cluster, which and all I have taken from C2, that belongs to C2 cluster. Like that I can able to segregate. Yes, there only I'm just showing. Same from here it will take. Okay, 2 comma 6, 3 comma 8, 4 comma 7, 3 comma 4 belongs to cluster 1, and 7 comma 6, 8 comma 5, 7 comma 4, 6 comma 2, 7 comma 3, 6 comma again 6 comma 4 will go to the cluster 2. Okay. Okay. So up to here it is clear, right? So how K means works and how K medioids work. Okay, just a minute. Just a minute. Okay. So now we are going to see another method in the cluster itself. What is the another method of creating the cluster? Okay, which is nothing but the hierarchical clustering. Okay, we are actually having so many clustering types like density based clustering, so many is there, but commonly used is either we go for the centroid based clustering or we can go with the hierarchical clustering. So from the diagram itself you can able to see it is looking similar like a data decision tree. right? So one root node is there, and so many leaf node is there. So many leaf nodes are there. So leaf nodes are nothing but the data points or entire data points. Okay. So from the data points, we will try to match the closest two points. Okay. This 2 point very close means this we will create it into one cluster. And from the close to cluster, we will again go for the another nearest to point. Okay, then that will become another one cluster. So similarly for here also, here if you see means maybe this point is very far from the next data point. So separately we are taking this as one cluster, and this 2 point and then the new cluster we can take it as another one cluster, and finally all the points will be taken as one complete cluster. Okay, that we will see. So hierarchical clustering is an alternative approach to partitioning clustering, okay, for grouping the object based on their similarities. So it is an organized and tree-like structure. So hierarchical clustering produces a sequence of clustering assignments, and at one end all points are in their own cluster, and on the another end all points are going to be on one cluster. Okay, all points on their own cluster. So all points are own cluster is nothing but the leaf node, and all points are in the one cluster means the root node. Okay, so here in the agglomerative clustering itself, we are having two types of approach. So one approach is we are called as agglomerative, okay, and the second approach is divisive. Okay, so in the here itself we can say like bottom up approach it uses the agglomerative, and top down approach used by the divisive clustering or divisive hierarchical clustering. Okay, so the steps of agglomerative will start from the bottom. Okay, you will be having individual points. Okay, in this case we are having A, B, C, D, E. So individual point will be grouped based on the closest to point. So here A and B will combine to AB, and here C directly going to the next step, and D and E will be combined as DE, and DE and C will be combined to CDE, and CD and AB will become ABCDE. This is agglomerative steps. If I do the reverse process, first all the points I will take it as one cluster, and from that I will split it into two halves like AB into one half and CDE another half. Then again from CDE I will check which is very far from each other. Then again I will split it into two halves. Okay, C and DE I will get, and again from DE I will split it into D and E. Here also A from AB I will split it into A and B. Okay, that is the steps of diversive. Okay, this is agglomerative. Okay, and how we are calculating the distance here in the k mean and medoid, we have found the distance based on the Manhattan distance, Euclidean distance, right? Here we will use the cluster distance measure. We are having three different types here also. One is single linkage. So when I say single linkage, assume that this is cluster one. One cluster is there and second cluster is there. From this cluster, okay, which is the very closest point to the cluster, and similarly from the cluster to very closest point will be there, right? Shortest distance will be found between one cluster to the another cluster, and if I am combining as one cluster means that we call it as single linkage method. Okay, whereas if I am taking the very far point from the cluster 1 and also from the cluster 2 I am taking, and I am finding the longest distance from one point to the another point, then that method we call it as complete linkage method. Okay, then we are having another method called average linkage method. Just a minute. Okay, so in average method, from each point from one cluster, we will find the distance of all the cluster, I mean all the points present in the another cluster. Okay, and we will try to find the average of it. So that method we call it as average linkage method. Okay, so and this diagram we are seeing, right? One point is there, and from that two branches creating. So this we call it as a dendrogram structure. Okay, it is a tree-like diagram that records the sequence of the mergers or split, we can say. Okay, uh, in the upcoming example, this is what we are going to see and how it is going to combine all the values into single cluster. So everything we are going to see. Okay, in graph, if I represent means this is how I will represent. But if I want to convert it into a proper chart-like structure means this is how it will create the structure. Okay. So agglomerative bottom-up approach. So these are the steps we need to follow. So we have to convert all the object features into a distance matrix. Okay. Then we have to assign each object to a cluster so that from the n object we have n cluster. Okay. So all the object should come inside an cluster and each object will individually will consider as an another cluster. Okay, so this process will be repeated until the number of cluster into a single cluster. Okay, all clusters should be merged into one single cluster. Until then this process will be continued. Okay, so at a time two points will be merged. Okay, once this 2 point merged means that pair will be merged to another one new point. Like that only it will perform its merging. Okay, so let us see with some example. Okay, so in this right hand side I have plotted in the graph. Okay, a b c d e I have pointed and these are the values to, so this is 2 comma 5 and c is 2 comma 4, d is 2 comma 2, e is 5 comma 4 and b is 6 comma 5. Okay, so if I ask you the distance, what is the distance between a to b? Can I say 3? So because A is present in here, B is here. Sorry, B is here. In between 4. Okay, 3 or 4 or something you can say. What? 4 I can say. What if I ask a distance between A and C? How 0? Here A is there. Here C is there. I can say 1, right? 1. Similarly for D also. A to D if I ask means what you will say? 1, 2, 3. Right. What if I ask A to E? A to E, if you're talking in a Manhattan distance method means we can say 1, 2, 3, 1 point and then here 4 point. Manhattan distance method. This is how we will draw, right? But in our case, this is not the case. So we have to use some formula to find the distance. Okay. That formula is nothing but we have already seen, right? Euclidean distance formula only. Okay, so using the Euclidean distance formula, I have to calculate the distance from A to A. It is going to be 0. So similar case for all other diagonal values. Okay, then I have to find between A to B, I mean B to B 0, so B to C, A to B, like that I have to find out. So if I perform this operation means, so this is how I will get it as my output matrix. Okay, so in this output matrix, if you see means I have marked, assume that this is a line. Okay, and this portion I have given it in gray. Why? Ah, yes, because it is nothing but whatever value you are getting below this line, same value only you have got in the above line also. So you can simply ignore these points. Whichever points are above this, you can simply ignore. Okay, and we can consider only the below points. Okay, because both are same only, this of that of same only, because B to C one it is taking 4.12 distance, means from C to B also same distance is going to take, so no any change in that, right? Then first step we have calculated the matrix for each point, one point to the another, and we have ignored all the repeated values. As another step, out of the remaining value, okay, remaining we are having these values, right? From that we have to pick the minimum value. So out of this minimum value means it is 1. Okay, and which 2 point is creating this one? A comma C. Right, A comma C is making the minimum value. So what I will do, I will merge A and C value as one single cluster. Understood? Then what I have to do, after merging, my matrix will change. So this is my original matrix. So this is my new matrix. So in new matrix I have joined the A C value. Okay, so since I have joined, only few points I have to calculate again. Okay, remaining points and all going to same only. These 3 points are same. Diagonal is going to be 0 always. Okay, so this is the repeated value only. So I have to find these 3 points alone. If I find this 3 point means automatically this 3 points also going to same only, right? So how to find from B AC I have to find, from D I have to find the AC, from E I have to find the AC. So for that, what we will do is we will use this particular formula. So from AC, I want to find the distance to B, right? So what I will do is I will split it into two, minimum of, okay, distance of A to B and then C to B. So A to B, what is the distance? We know A to B, 4, right? And from C to B, 4.12. Which is the minimum value? 4, right? So I will take 4. So we got here as 4. Okay, here 4 means here also 4. Same goes for from AC, I want to reach the D. Then I will find AD and then CD. Okay, so here out of 3 comma 2, 2 is the minimum value. So I will update my matrix. Okay, again from AC, I want to find the distance of E. So AE and then CE. So A is 3.16 and then here 3. So obviously I will take 3. Okay. Now by seeing this seeing this matrix, what is going to be my minimum value? 2 is going to be my, how 4? 2 is the minimum value. Okay. Okay, not even 2. Sorry, my bad. 1.41 is the minimum value. 1.41 is minimum than 2, right? So that I have forgot to see. Okay, so which 2 points creating that minimum value? B and E are creating that two value. So I have got AC already I have got. Now I will join BE also. So once I have joined BE means again my matrix will change. Again I have to find the distance. So this time the number of finding the distance will also be reduced. Okay. This time I need to find only 2 points. So from BE to AC I want to find, and then AC to BE same only. From D I want to find the BE distance. So what I will do from AC to BE, if I want to find means I'm having four different possibilities is there, right? So out of this four distance value, I will find the minimum value. Okay, in case if you are matching AC and BE, okay, so A, B, or what are all the combination is there, all combination you have to find, and in that you have to choose only the minimum value. Okay, and from D to BE, you know, right? What you will do, you will find the minimum of D of what? BE, sorry, BD, and then distance of ED. Okay, DED both are same. So what is going to be my value for that? Minimum of BD 5. Then ED 3.6. So obviously this is 3.6 and this is 3. Okay, Vandal here I will put 3 and here I will put 3.6 if I'm right. Okay, okay, I think 3.16 somewhere I have made any mistake. Okay, this is 1.6 or 6, you just check it out. Uh, Okay, then so from here, if I choose the minimum value means 2 is going to be the minimum value. Okay, even if it is 3.6 or 3.16, anyways 2 only I'm going to take. And for 2, which two points are matching? A, C and D are together matching. So AC already one cluster, and from AC to D I'm creating another one new cluster here. Okay, and B and E we have already found. Now after combining all these three, okay, A, C and D, okay, and B, E, we have to find the distance in these two places, okay, between A, C, D, what is the distance of B, E? Okay, so for this what we are having six combinations are there. Okay, so out of the six combination, three is the minimum value. So I will replace it with three. So obviously, three only one point is there. Even if I'm calculating or not calculating, also I can draw a complete cluster, right? Already A, C, D is there. Then B also joining means complete cluster I will get. A, C, D, and then B, E. Okay, so like this I will get one entire cluster. So this is what method? Agglomerative method. And if you are drawing a diagram for represent means that we will call it as dendrogram diagram. Okay, these technical terms you need to remember because when you are using algorithm means those terms will come. Okay, then it has not completed yet. We are going to see the reverse process, and this method is nothing but the divisive hierarchical clustering technique, okay, which is a top down approach. Okay, initially I will say all points as a single cluster, and then I will do different operation, not reverse operation, similar like that average, finding the average I will find something. So that also we will see. Okay, okay, do you want to explain this into this class itself, or shall I take it to next class? Okay. Then I will explain about this diversive hierarchical clustering technique in tomorrow's class. Okay, and then we will see one algorithm also. Okay, with the uh, program and code will be there, because too many theory one day means boring only. We will see how we can do the hierarchical clustering, that agglomeration method we have theoretically seen, right? That by using one data set, similar like we have seen in k-means, one algorithm, I mean one data set we have taken, right? Customer income and spent. Similar data set, but along with the two column we will have few more columns also, like age of a person, uh, two three things will be there. Okay, from that we are going to find the hierarchical based clustering. Okay, how much spent, how much income earned, okay, how to create a cluster, everything we will see. Okay,